Thank you everybody for coming today for our April 11th class on quick guide to commercial code. We will be offering Doppel credits for those that are here in the class today, so please make sure that you've registered. We'd like to thank the Utah Office of Energy Development, Dominion Energy, and Rocky Mountain Power for sponsoring this event and being able to offer breakfast and Doppel credits for free today. We do have another class on May 23rd coming up that is field training for duct sealing if you guys are interested in that. I will go ahead and pass the mic off to Brent and we'll get started on commercial code today. Thank you.
Thanks, Jacqueline. Great to be here. Quite a few familiar faces here. Nice to see you guys and meet you guys. Control people I have here on the front row. Somehow someone told me there's some lighting controls in the energy code now. I think, just quickly, I'll introduce myself for those that don't know. My name's Brent Ersenbach. I'm retired HVAC contractor, retired building inspector, and started in HVAC in 1972. So if you do the math, that's 51 years that I've been involved in this industry. Originally, what we talked about, I'm going to grab a pointer out of my bag, was we would do a class where I produced a quick guide that was similar to what we have for the residential energy code. And I think those that are inspectors and plans examiners in here are familiar with my residential quick guide. And it's a one-page document printed on both sides that kind of walks you through the residential energy code and your options there. And in March, we did an introduction to the 2021 IECC commercial provisions. And I ran through that quickly. We didn't finish. And after that class, I've received a lot of comments. And over the last few weeks, I've received a ton of questions as people are starting to study the code. And they're basically saying, I am so confused, I don't know where I'm going. And so I tried to put together, anyway, I have a little document here that I've passed out. And I started making a list of things that I would look at if I was reviewing a larger commercial project. And it doesn't even include everything that I'd look at. And I've come to the conclusion that we can't do a quick guide for the whole thing. And what I'm going to work on through the coming year, and for Lon and other people that are working in plan review and such, is I'm going to produce quick guides for different size buildings. And we are going to do, give direction on what do you do for a small medical building, the single story or two story. What do you do on a convenience store? What do you do on a dentist office? What do you do on a moderate sized office building, 3 or 4 stories? Because a lot of stuff in this code doesn't apply until you get over 25,000 square feet. Some's 100,000 square feet, and there's a lot of different things in here. And some of the things we'll talk about today don't apply in most of what you're looking at when you're out there, either at a plan review desk or at a table. We have an electrical engineer in here today. The gentleman right over here with the glasses, what do you do?
Oh, sorry, my name's Amber, Salt Lake City.
You're in Salt Lake City, okay. So we have 4 or 5 code people in here, maybe a couple online. We have some controls people on the front with Leviton and who are you?
Steven Sales.
Steven Sales. And Kyle is an electrical engineer. So I'm going to try to share something that is beneficial to all of you. Please feel free to add your expertise or, correct me or add something to the discussion. We're going to go for about 3 hours. We'll take a break halfway through for 10 minutes just so you can get up and stretch your legs. And we probably won't get through everything, but hopefully we have a meaningful discussion. I want to just say lastly, before I get going with the slides, please feel free to reach out to me with your questions and even most importantly, if you have suggestions on what you think would be beneficial out in the field. What you guys see as your bidding projects on the control side, what weaknesses are there. And moving forward, keep your eyes open because I'm anticipating in the coming year, maybe we'll do a couple of classes on smaller applications of the commercial energy code, because it all doesn't have to be that complicated. A smaller building can be quite a bit simpler. And as Jacqueline mentioned, these are provided at no cost. We do about a dozen a year through the generosity of Dominion and Rocky Mountain Power and the Office of Energy Development, and that's who pays me to be here and do this, so appreciate their support. The commercial energy provisions, as with any code, the energy code, Chapter 1 is administrative section, Chapter 2 is definitions. And with the 21 code, there are a lot of changes, a substantial number of changes. And these are some of the things that they added are things that I have been calling out when I did plan reviews because I consider them important. In Chapter 1, it does recognize that you can do digital format, and I think almost everybody is doing digital now. I don't know anybody that's doing paper plans anymore, or very few are doing paper plans, especially on a commercial project. By the way, if it's in blue, it's highlighting a change to in the 21 code. It's new or different. And so digital format's finally there, probably 6 to 9 years behind when it should have gone in. But we've already had the discussion, haven't we, on how long it takes to get something in the code. It's a 6 to 9 year process to get something in the code. And identifying the air barriers on the plans so you know where the air barrier is. Up above the energy compliance path. That is one of the biggest weaknesses I see as I've reviewed commercial and residential projects is we have a set of plans, and if you want to review energy, you are searching the whole set of plans looking for where are the R values, where are the U factors, where is there a lighting schedule that includes everything that is in the building. And we just don't have complete plans as far as the energy code side goes. Our engineers and you guys, if you could take something back to your design professionals, I would ask you to suggest to them, and I've been announcing this nationally when I'm at ICC events and such, we have structural pages, we have architectural pages, we have mechanical pages, we have electrical pages, all in a set of plans. Why don't we have energy pages where we identify all the thermal performance characteristics and specifications, all those things that we are going to talk about today, where they're compiled on one location in the plans rather than searching all over the plans. Most critical is the thermal performance. And with that, I'm going to throw in my favorite soapbox subject is that I preach about constantly is the plans say one thing, the specifications say another thing. You're laughing. You've only seen it once, right? The plans, the specifications, the heat loss and gain calculations say another thing. They all have a different R value. They all have a different U factor. They all have a different, everything's different on all of them. And so consistency on construction documents is probably my number one pet peeve. I put a blue note on here, the building thermal envelope shall be represented on construction drawings, not buried in specs. That's not enough, and besides, we know specs are often boilerplate, and they haven't been updated, and I guarantee you the first few plans that you review on the 21 code, you're going to find it even says the wrong code on your plans. It's going to say the wrong code in your specs. Previous to July 1 of this year, or until July 1 of this year, we are on the 2018 commercial provisions of the commercial energy code. I did residential yesterday. And what our options were, and they're similar, but there's some differences, and there's some big differences. But the first thing is we have to make a decision. Which code are we going to use? And I have this on this 9-page quick guide. I have that identified here, that on the code you pick which are you using, the 2021 or ASHRAE 90.1 2019. And I put the version of 2019 for ASHRAE because I get that question all the time. If we want to go ASHRAE, which version is it? It's the one that's listed in the adopted IECC. And so when we adopt the 21 IECC, it's going to be the 2019 ASHRAE because that's the reference standard. So you have to make a decision. Now, I think it's clear back to 2009, you could pick and you could use ASHRAE for maybe your envelope, and you could use IECC for your mechanical, your lighting, or a different selection. You can no longer mix and match. You have to pick one and stick with one. Why would we want to cherry pick between them? Because sometimes ASHRAE has something that they don't want to do, or IECC has something you don't want to do. And a perfect example is receptacle controls. And guess what? The receptacle controls are in the 21 IECC now. So that has gone away. There's still and I'll bring it up because if we might not get to it. The IECC is very confusing on economizers. And as I read the IECC, all these apartment projects that are going up right now should have economizers because the total BTUs exceed the limit in the IECC. And I've asked ICC for an interpretation, and they said, well, yeah, I guess that's what it says. And I think that's foolish because there's no way you can ever justify the cost of putting an economizer on a 1-ton system or a 1.5-ton system. You'll never, ever produce enough savings in a residential unit to where that would pay off. So the decision's been made. We're going to focus primarily on the IECC. Until July 1, we can use the 2018. We have all these sections we have to comply with. And on the lighting side, I'm going to mention this to all of you code officials out there. You should get a comm check for that envelope, mechanical, and lighting, and your service water heating will be tied in with your mechanical. You should have 3 comm checks when you get comm checks for a commercial project. And actually there should be 4 because the lighting will give you an interior and exterior. Lori?
So on the comm checks, they'll have, like at the top, use enhanced lighting, whatever. Do all 3 of those have to state that?
That's a great question. I'll repeat it for those that are online. Her question is, so we have 3 comm checks, and at the top you're supposed to, it requires you to list an additional or enhanced energy efficiency selection, right? Or option. And these currently are your options right here. We have 8 of them in the 2018 code. And really they should be the same because they overlap a little bit in some cases. Now in the 21 code, you'll see they have to be the same. In fact, we might get some points from mechanical, we might get some from lighting, and we might get some from the envelope. This is one of the bigger changes in the IECC is that additional efficiency selection or option that you pick. and it's a substantial change.
Actually,
Kyle.
I had a set of plans where the building shell used one path, and then the TI, I tried to use a different path, and they rejected it. They went back and looked at the building shell and said, no, you approved the reduced lighting. You have to use the reduced lighting for the entire thing. You can't use enhanced lighting control for your TI to squeeze some more wattage out. I'm like, oh, okay.
Actually, but with the 21, you can get a little bit for lighting, you can get a little bit for the envelope, and so there is some mixing. But you're right. No, the way the code's written, you pick one and it applies to all of them. What it really, here's one of the big things, and I've been asked probably 50 or 60 times, well, which one do you want us to do? I don't care which one you do. And I'm not saying this is a negative, Kyle, but the design team needs to have some communication so that they're all working in unison. And the 21 code really pushes you that way, where you need to do that, especially because you're going to almost have to, in many cases, bring these gentlemen in on the lighting control side in to comply with the code. It is not easy to comply with the 21 code. Well, it's different, let's put it that way.
You need us.
You need the lighting controls, and lighting controls are becoming huge. In fact, that was probably one of the big hangups why we have not adopted the residential side yet, and maybe we will next year, but the 21 residential code has a lot of simple lighting controls in it. And there's so much resistance to it when, you know what, there's some great little products that can be used in the small commercial that I use in my home. I replaced my outdoor light switch. I call it an astronomical timer. You guys call it I can't remember what you call it, but you know what I'm talking about. It's great. I program it. I put in the time. I put in my location and everything, and it changes when my lights turn on and when they turn off based on the day, because it knows where the sun's setting and when it's rising. And it replaces a light switch. It fits in the same box. So there's all this opposition to these lighting controls that they're so complicated. And I have occupancy sensors in my garage, the light that's over the fridge, because that's where the grandkids head to get a pop or something like that, and they leave the light on. So you walk out, it turns on the light. When they go back in the house, it turns the light off. So I guess what I'm championing, that some of these things are not very expensive, and they're wonderful, and they're energy saving and everything else. But, that's where we're at. And our last option, of course, is the performance approach, where there's an energy model. And I don't spend a lot of time on energy models because an engineer runs that, usually the mechanical engineer. They do the modeling. The only thing I look at that is that the thermal specifications that they're using in their model match what's on the plans. So the compliance path on coming up, and I'm trying to make it simple, more simplified, is all of this is the same. We have our administrative rules, what required for a permit, the documents and all that stuff, our definitions. Climate zones, they change the requirements. Not on these guys' side, but the envelope side changes for the climate zone. We have energy efficiency for the building. We're going to go through here. We're not going to talk really about the existing buildings, other than let me just put this out there. I always get questions, and by the way, grandfathering is not a word in the code. All right?
It's not in the definitions.
It's not in the definitions. I don't know who came up with that word, but or it's better than it was, is not in the code either. But anyway, on existing buildings, if you do something new, what you did has to comply. If you change the windows have to comply. If you gut the building, the whole interior has to comply. If you touch it, it has to comply. And there are some, Chapter 5 is existing buildings in the energy code. If you have questions on that, get a hold of me. But anyway, so we pick a code, we pick the IECC, and it basically tells us we have two options, and that's really what we talked about here. We have the prescriptive or the performance, but we have a second option in the prescriptive, and that is what we call our trade-off, our ComCheck envelope trade-off. And so this looks like we have two options, this looks like we have two options, but we have two options within the prescriptive. You either meet the table completely 100% or you trade off a weak component for, just like we do on the residential side.
Through a com check.
Through a ComCheck, an envelope ComCheck. What's the advantage of performance? You get to trade off crossing over. You get to trade off lighting for, poor envelope. I mean, how do we build all these big buildings that have lots and lots of glass, more than 40% glass? It's by trading off with high-efficiency lighting and high-efficiency mechanical through a performance model. That's the only way you can do it. And then we do have commissioning requirements when we hit certain sizes of buildings. So it's IECC or ASHRAE, no mixing. Prescriptive includes tables, or we do a trade-off with ComCheck, and commissioning depends on the building size. Now, I'm going to admit that I don't read things very quickly or very well when I open something on the internet sometimes. I went to download the new 2021 ComCheck. Hit download, went through the whole thing, went and opened up ComCheck, and I didn't get a new ComCheck for the 2021 code.
I see that this is like a basic, it's like an example designer, design for web.
Just a second, he's gonna bring a mic.
Just,
And then I need you to speak up too.
just real fast, this ComCheck web thing, is this something that, like, anybody can get on there and do examples and do full anything on this website here?
Yeah, that's
Like, I want to
what.
play around to learn it, you know what I mean?
Yeah, oh yeah, yeah. So, great question. So I think most of you are familiar with ComCheck, free from DOE. I've always used ComCheck and ResCheck that I downloaded on my computer so I could work on it wherever, or I could mess with it and get familiar with it, right? And I think that's your question.
So there is an account, so up at the top part, right, you can see where he's logged in. If you don't log in there, it doesn't save your work, but if you log in, it's a free account. And so it's just becomes a cloud-based version of what the desktop thing was. I've been using this for years, so my project list is huge in here, and it just saves your work.
It doesn't matter. I mean, I see him coming in for the plan exam, in that exam, excuse me. But it's like, I think it's better that, with the new code, that we'll get more familiar with this new setup. I was curious about it.
The
You're-
reason why I shipped it back in the day was just so I didn't have to download every revision.
Every revision. That's
This kept it up to date.
That's great. Yeah, Kyle has mentioned that, if you didn't hear him, he just uses this so you don't have to update your version, and I guess you're not storing it all on your system either. So, yeah, there is no restriction. If they see that someone's gone on and they've created a project and they've just messed around and they've never finished it, they don't care. You could,
You don't even have to log in. If you don't
Yeah.
log in, it just goes away.
yeah. But if you're playing with one and you want to come back to it, go ahead and call it sample one or whatever, and go ahead and mess with it. What I failed to recognize is that in 21, this is all that's available. And I tried 3 times before I read what they were telling me, that I don't have a downloadable version. I have to do it online. And
Going backwards, this is only available back to 2009. So if you're doing like something in Arizona, then you can go back to 2006. You have to go back to the desktop version instead.
Yeah. Yeah, it's only supported back to 2009 on the website. In fact, that's kind of something that's going to affect Utah, because Utah still has a version of 2012 res check, and that will probably disappear in the next 3 years or something like that, support for that version. So anyway, this is ComCheck Web, and guess what it has? Envelope, interior lighting, exterior lighting, and mechanical. And so you will generate each one of those. And notice it says credits. Those are credits towards your enhanced or additional efficiency that we'll talk about here a little bit later. So be aware for reports, and this is the only way you can do it. And I understand why you're doing that, Kyle, because it makes sense to let them store it. That'd be nice not have to do that update on my documents.
And I can send architects there. They can, you teach a man to fish and you can go do that himself.
Yeah, you can teach architects, and you can exchange, and easy. Okay, a few definitions, and I'm going to run through them real quick. We talked about this in our last class, but as we're moving to sustainability and in our buildings, and that's a big push, they're trying to define things a little bit closer. Biogas, people have been calling natural gas biogas and trying to get credit for it as a biogas. And natural gas, I guess, is a biogas from fossilized fuel. It's a fossilized biogas, but or coal or whatever can be considered that. And they're basically talking about what we might take out of a landfill. Yeah, it's still natural gas, but it's been generated, kind of locally. Biomass, non-fossilized, biodegradable organic material, and then it's talking about the places we get this. We're not going to spend a lot of time. On-site renewable. I believe, and Kyle, maybe you can add to this, I believe that we are going to see more and more solar going on buildings because of the 21 code, because it's going to get you over the hump on the credits that you need.
I think that's probably going to be a bridge that's going to be hard to adapt, it's going to be hard to cover, because that's usually a separate permit. So you might say, hey, we've got this break line where we're going to fill it in with solar later, but the permit's going to come later, so we don't know what it's going to be. So I don't know if this is going to be something we can have that kind of a break between the permits and, still say claiming it.
Well, I don't think we're going to be able to. His comment was, we want to do the solar later. We're going to prep for it. We're going to be ready for it.
It may not even be constructed later. It might just be kind of like your sign has always been a separate permit,
Yeah.
As long as you sign up front, we're constructing at the same time. It's just the fact that the city wants to be able to prove that different.
Yeah. Well, the challenge, and I don't know if you've looked very much at the credits, depending on the type of building, sometimes some PV might push you over the 10 credits, and we'll look at an example here in a bit. Obviously, where we are right now, there's not as huge an advantage for us as it is, for instance, in California, where in California the residential customer pays more for your power in the afternoon, right?
Evening,
Yeah,
4 to 9,
yeah. You
it's shifted.
yeah. You pay more for power in the heat of the day. You pay more for power when you first get home. My son has his cars programmed that they don't start charging until 10 o'clock because power's cheaper at 10 o'clock. And if you have an air conditioning demand in that heat of the day, then PV becomes a lot more viable because it can save you a lot on your electrical.
Yeah, PV without batteries, backup storage doesn't pay off anymore.
Yeah.
Very simple.
Yeah, It's still in its infancy, but I expect we're going to see more of this. Renewable energy resources, I'm just going to skip through it. These are our renewables. Climate zones, real briefly, climate zones are basically temperature or climates. Well, they are climate zones. And our requirements change based on our climate zone. And if you notice, I have a note at the top in Utah, Box Elder, Cache, and Carbon counties all shifted from Climate Zone 6 to Climate Zone 5 for the 21 code, because their historical data has kind of shifted a little bit. They're a little warmer than they were, and they passed over that heating degree day definition of a climate zone, and they,
That was last year.
well, it happened with Ashray already. But, yeah. Anyway, we had a change here. If you notice, just right down in here, they pick up Carbon County. Low energy buildings and greenhouses. And I think maybe there's a couple other things we should add on to here, but previously, all the code allowed was a low energy building. That's a building that used 3.4 BTUs per hour or 1 watt per hour per square foot, or 1 watt per square foot of floor space. And I had lots of people say, well, we're building a warehouse, we're going to put in a couple of 50,000 BTU unit heaters just to keep the pipes from freezing. It's a low energy building. Well, that doesn't meet the definition at all, because that's way more than 3.4 BTUs per hour per square foot. And I'll just give you a quick example. To meet that definition and not have to insulate a building, you would have to, you build a 1,500 square foot garage, 30 by 50 garage. And for it to qualify as a low energy building, all you could put in it was a little plug-in heater that you bought at Walmart that's 1,500 watts. What's that going to do to that 1,500 square foot garage that has no insulation? Absolutely nothing. So this is a tiny amount of heat. I haven't seen anybody ever qualify for it, other than one instance where they had a large warehouse space and they had a little tiny bathroom, a toilet and a sink in that warehouse, and they just heated it. And they put that in there. And they were able to get away with it because they were just heating a confined space. I guess a pump room or something like that might be able to do it. But they have added in the 21 code the greenhouse structures that are mechanically heated or cooled, and they have some things that they need to comply with. They do have to do some things to the envelope, but they don't have to meet the energy code based on it being a conditioned building. Because why are we heating a greenhouse? It's the process. It's the, quote, manufacturing process. So a greenhouse has limited requirements on the windows and the envelope assembly. You have to do a little bit, but you don't have to go crazy on it. This has been in the code, but it's changed just a little bit. Equipment buildings for cell towers and such, phone switching. Basically, what they're saying is they don't need much heat. They generate a lot of heat. Depending on your climate zone, a U factor, average wall and roof U factor of 0.2 is basically an R5 envelope. That's not a lot. And for climate zone 6 through 8, it's also, it's a R8.3. But you have to have a reflective roof as required for climate zone 1. So you don't have to do a bunch of crazy stuff insulating those, because they're producing so much heat, and the only thing you're worrying about is cooling it. Here's our discussion on, and I have it on our sheet here, on how much window area can you have. Buildings have vertical fenestration areas allowed by the code of 30 or 40%. 30% is the standard number that we've heard for a lot of years. You can't have more than 30% glass. You have an exception to go 40% when? When you're using these guys' lighting controls. Because we have more window, we are going to have more heat transfer through it, but we also have a big benefit because we can use natural lighting in our space if we can use it with the proper controls. That we shut off the lights when we're able to use that light. And the same thing goes for skylights. You can go from 3% to 6%. And in fact, there are some requirements that at warehouse type spaces, you have to put skylights in. Prescriptive approach tables, we're just going to fly through this. I think most are familiar with it. If you want to comply prescriptively, you got a table that tells you what you need to put in. For instance, for your roof, a roof in a metal building, here's the insulation requirements. If you have an attic, here's your insulation requirements. If you have I didn't enlarge the section, if all your insulation is on top of the roof deck, we have an insulation requirement. Walls above grade, same thing. Based on climate zone and whether it's a group R or others. Most of the times they're the same, but they do change a little bit. For instance, in our climate zone, for a mass wall above grade, if it's an R, a residential occupancy, you have to have 13.3 continuous insulation, and if it's a different, all others, anything but an R, it's 11.4. What is a mass wall that would fit in this table? Anybody got an idea what we're talking about? A mass wall that's insulated with tilled up concrete, exactly. You see how they're building tilled up these days? They pour concrete, put in the pins, drop the foam on it, pour the next layer of concrete, and they sandwich the foam between the layers. It's a little bit expensive, but boy, it solves all their insulation problems. And they don't have to have that much insulation, 11.4 is like 2.5 inches. They get it easily with that.
So what's the difference, can we go back? What's the difference between metal building and metal frame? Is it like a
Great question. What's the difference between metal building and metal framed? The metal building, and in fact, and I don't think
like the manufactured metal buildings?
Yep. Metal buildings. These are the manufactured metal buildings with the big beams and the purlins and the metal skin on them. And there's a whole, when I first became involved in energy code, when I became an inspector from a contracting side, there was a lot of complaining by the metal building people. What's their big claim to fame? Low cost. They build low-cost building. They drape insulation across it. They squash it when they screw the skin on and such. Well, we start adding requirements. They have to have thermal blocks so that we maintain some continuity on the insulation. We now have gone to, it says, in fact, I do have a picture in here. Climate Zone 6. Change from, it's now R30 plus R11 LS, which is liner system. I got a slide, I think, in here. But basically what it is they run R11 across the purlins. And they let it kind of sag. And then they put the R30 laying down between them, kind of like a cavity insulation. And then you put your metal skin on it. The liner system is to solve the condensation issue that we always have in those metal buildings. Because what happens with the metal buildings, you have these beams that are thermal bridges between outside and inside, and they drip and they condensate all winter long. And so they put a vapor barrier, a liner vapor barrier under the whole thing that covers all the metal. And that's what a liner system, and it's mandatory in our climate zone. And I think I have a picture in here a little bit further on. That's a great question, Lori. Walls below grade. They're listing, of course, the continuous insulation there. Floors. The requirements there. I'm just going to skip through unless someone has a question. Unheated slab-on-grade floors. We have mandatory requirements now, and you're going to get a lot of pushback on those. Opaque doors, they've tightened that up a little bit. You need a lower U factor. And there's our metal building slide. So we have the we have the R11, we have the insulation draped over the purlins, and there's the liner installed over it. See how we're covering the metal. Minimum skylight areas. Again, stop me if you want to talk about something. If you have this size of a building, greater than 2,500 square feet, at least 15 feet high, you need at least 3% skylight area to the top lit daylight zone. And we have a VT for those. We got so much to cover. I'm going to keep moving unless you got something you want to talk about. Big change in the code. We have kind of given garage doors a pass in the past. And allowed garage door manufacturers to just say, well, we're going to put R3 or R5 or R15 or whatever in the panels. They now have to have a U factor. So how are they going to get a U factor? They're going to have to get the doors tested, and they're going to have to account for the thermal bridging that goes through the metal on the garage doors. Air leakage. There's a lot more blower door testing in commercial buildings coming into the code 21. In both a dwelling, sleeping units and other buildings. And we have in blue, operable openings, interlocking. Anybody have an idea what I'm talking about there? Restaurants that have a garage door that goes up or a wall that accordions open. We actually have a requirement in the code now that it shuts off the HVAC system while the door is open so that we're not trying to cool outside. Sometimes they open those doors when it's a little too cold outside and the system's running overtime to try to keep the interior customers, like my wife that need it 73 or 74 degrees. So how do you blower door test a commercial building? You might have to put a lot more blower doors in. And if you read the code, be careful on this, because I've read it like 3 or 4 times, and every time I read it, it seems like it says, you have to test everything, but then you refer to the table, and you only have to test, well, there's some exceptions to the testing. And we'll get to those in a second. But how do you test? And this is a change. Commercial buildings have always tested at 75 pascals. What do we test a home at? 50 pascals. They have now added that we can test dwelling units at 50 pascals. All others we test it at 75 pascals. And we have triggers. So our dwellings, generally most of our dwelling units, our apartments now, are going to need to be tested, because none of these are our climate zones. We're 3B, 5B, and 6B. And so we will need to test apartments. In other buildings, we're going to have to test a lot of them too. but we're going to have to look closely at the list of exceptions that I didn't include. That's just the testing procedures. I'm going to jump through it. Envelope performance verification. The code says now, and this is the top one is what I want you to be familiar with. The air barrier installation verified by code official, registered design professional, or an approved agency. Building departments, you're going to need to decide, are you going to certify or verify the building performance, that air sealing, or are you going to require third party? Because reports need to be submitted.
Is that considered as a special inspection?
Could be, yep, yep. Kind of like we have, because all the stucco problems we had 15 years ago or something, we have, in many cases, you can ask for special inspection on stucco. It's a similar thing. Here's our operable opening interlocking. And it's in two sections in the code. It's in the envelope and it's in the mechanical. If the door is greater than 40 square feet, that's not a very big door. Must be interlocked with heating and cooling at the following levels when it's open. Raise the cooling set point to 90, lower the heating set point to 55, and we have some exceptions there. But generally, most restaurants are going to have to meet this. I doubt this is a control that you guys will sell. It's going to be a control that the HVAC suppliers will provide. It's basically going to have to be a door switch that triggers, a setup or set down, depending on if we're in cooling or heating mode.
So is this all verified like during the commissioning of the building?
This should be identified, obviously, at plan review.
This is already done in some of the codes with hotel guest rooms. Something extremely similar within 20 minutes of, like Title 24 has within vacating the room, within 20 minutes
Yeah.
of vacating the room, it has to change 5 degrees one way or the
Yeah,
other.
and we have that in the code now. We do have in the code now,
So this would just be
Room.
an extension of that, monitoring the door switch.
yeah.
But for inspection purposes and verification, is that all part of the commissioning report? Would that
Well,
be verified?
Well, guess what? You're not going to commission these buildings. Rarely are you going to be commissioning a restaurant.
Just because it's not real?
It's not big enough.
So it'll have to be shown on plans.
It has to be shown on plans, and you're going to have to verify it. So that's a great question again, You're thinking in the real world. I'm just talking about all this crap that's written on paper, right? That we're trying to figure out what it says. That's a great question. But it's one you're going to have to really pay attention. They put those doors on there, and it's very popular, whether it's a garage door or something like that you open up.
And kind of the same question with the daylight controls. What, are you going to go out and inspect the building at night?
Well, you have the functional control requirements that are part of.
They have a functional test, don't they?
Well, it's part of the functional testing portion of the lighting control system.
So like a commissioning report or?
It should be normally done through that, the building management systems in all the buildings. They have a reporter in there.
Well, some are, some are tied, you tie into some BMSs, I assume.
Yeah, a lot of them.
A lot of them, yeah.
It's just a question of whose responsibility that functional testing is.
Yeah.
The code calls out that it needs to be a third party that actually goes through and tests, but as you pointed
Yeah.
out, it's only in certain situations.
Yeah. It's just another thing that you need to be aware of, right? That's why, this is why compliance is so low, because how many are here? How many, in 3 years, how many building inspectors and plans examiners will be aware of this or these other requirements in 3 years? We'll go a whole code cycle, and we'll have a lot of jurisdictions that haven't even looked at it. Again, great questions. So, our additional efficiency credit, section 406, a complete section in the code, it now doesn't say pick one of those 8 items. It says you need to have 10 points. And you get them for more efficient HVAC performance, reduced lighting power, enhanced lighting controls, on-site renewable, dedicated outdoor air systems, high-efficiency water heating, enhanced envelope, reduced infiltration, where not required energy monitoring. You know, there's some cases that you have to monitor their energy. Where not required fault detection and diagnostics and efficient kitchen equipment. So you guys pick up 2 of those right off the bat. And so to comply with the code, and we're going to get to some tables on that, you might have to pick from a couple of these to get your 10 points. Or they might have to pick, you know, and present to you as a code official to get your 10 points. And here's an example, and if we have some time, we'll look at some others. Now, I want you to pay attention to this one because this is a Group B occupancy. What's a Group B? Business offices, right? Okay, how much hot water does a business office use? Hardly any, does it? So if we look at the 3 service water heating options that you can get credits for, what does it say by them all? You can't get any. Because if you put in a, quote, ultra high efficiency water heater, but you're only using 50 gallons of hot water a day, you're not going to get any credit for that because that's not an energy user in your building. But where do we use energy in a building? And this kind of tells us, if we look at this, by being 5% more efficient in cooling, depending on our climate zone, if we're in a hot climate, we can get 6 or 5 or 4, and as we get to a colder climate, here we are, we only get 2 points for improved cooling efficiency by 5% in our climate zone 5B. And if we go 10%, we get 5 points. Now that's better. Why don't we get anything, hardly anything on our heating? We get 1 point by 10% improvement on our heating efficiency in that office building. Because B occupancies don't have a huge heating load because they generate so much heat internally. They have a cooling load because they generate so much heat internally, but they don't have a heating load. And we don't get as much credit as the hotter climates because why? Because we can economize more than a hot climate. We can get free cooling with cooler outside air. We cool down every night, right? Virtually every night. And so we can cool a building down for a good portion of the day and into the morning with economizer. But in Phoenix, Arizona, you cool all the time. So the tables, and there's like 5 of these tables for different occupancies, and you get credit based on what it is. There's the B's, there's the R's and I's, there's the E's, there's the M's, and then anything that doesn't fit that. And you have a table for each one, and it's going to change. And guess what? If it's a multi-family, you're going to get credit for hot water because there's a lot of hot water used in multi-family. If it's a school, you're going to get some credit. If it's a hotel, you're going to get some credit. Any place that uses a lot of hot water, you get a lot of credit.
What's LPA?
I'm sorry?
What is LPA? Like the 5th one down?
Your lighting power. And so high efficiency lighting, your lighting controls. Commercial updates, and I'll try to move through real quick. Anybody know what that is? It's a packaged air conditioner it's for a data center or computer room. It's a computer room cooling system. Not a data center. Data centers are bigger. They're going to have big, this is for a computer room. The cooling, the compressors are inside, and just the condensers on the roof. In fact, here's 2 compressors and here's 2 fans is what we have. And I want you to look at, these are what we call axial fans, which means they're like a propeller type fan rather than a centrifugal fan that's like a blower wheel. And we're going to talk about fans here in a little bit because guess what? Axial fans are much more efficient than centrifugal fans. These are the areas that we have a lot of changes in the code. I'm not going to read the list. It goes on. What big ones that we do need to pay attention, though, are our refrigeration equipment. Needs a lot more attention now. When we do a restaurant and they add refrigeration, or if you do a refrigerated warehouse, we have much stricter requirements there. And as we mentioned earlier, HVAC, guest room HVAC controls. Not only do we have lighting, but we have HVAC controls on our guest rooms. Information technology equipment, computers, data storage devices, service, and such. So these are all a new definition in the code. A data center, and that's where I misspoke just a minute ago. The IT equipment power density exceeds 20 watts per square foot. So they generate a bunch of heat. Anybody seen the Facebook buildings they built out in Eagle Mountain? Did you get out to see them, or you just heard of them?
Just seen them out there.
Huge, huge buildings. Can we even imagine how much heat they generate? We'll have slides in here in a little bit. Guess how they cool them? Evaporative cooling, 100% evaporative cooling. That's kind of crazy, isn't it? No chiller, 980,000 square feet, racks of computers that extend, it's built like an H, 1,200 foot long legs on the H, with racks of computers that run the full length of those H's, and they don't have a chiller in the building.
Factory, right?
I'm sorry?
It's a cloud factory, they're generating clouds.
Yeah. They have a huge water reclaim system in there. They don't throw, I mean, of course they evaporate a lot of water, but what they don't evaporate, they remove mineral and everything. If you pay attention, you see them when you fly over. They built like 3 buildings like that now. Computer room, this is the smaller ones. These are what you're seeing in office buildings around here. They're not dedicated data centers. Direct digital controls. I love this. As I was getting out of HVAC, they became more and more prevalent. The first job I ever worked on as an HVAC contractor that had, quote, digital controls was in the early 90s, and it's nothing like we do today. My oldest boy works in building engineering, and I actually got this screenshot from him off his computer, but he can change set points, he can troubleshoot, he can do everything off his cell phone because of the data collection and the controls that take place with direct digital controls for your HVAC, and it ties into your lighting systems and everything else. BMS is building management system. And this one is an important one I want to point out because Here's our air handler. We're bringing air in from outside. No, we're exhausting air there. We're bringing air in from outside here. Our return path is this way. And we have a heating coil, an indirect cooling coil, a chilled water coil, and an evaporator coil. So we have 4 stages of cooling. We have economizer bringing air from outside if it's cool enough. That'll cool the building. Indirect cooling. What's indirect cooling? That's when you take cooling tower water and you're able to cool the water with the cooling tower down enough that you can circulate it through a coil and get cooling into your building. It's evaporative cooling, but we're not bringing any humidity into the building. We evaporative cool it in a cooling tower, pipe it in, run it through that one. Chilled water, that's hooked to the chiller, and this is a giant evaporative cooling pad. And so we can, oftentimes, in fact, typically if this is done right here in Salt Lake, you don't have to turn the chiller on until July because we can do all of our cooling with evap cooling, indirect and direct evap cooling. Fault detection and diagnostics become very, very popular in recent years. Economizers, there's been a lot of studies. You go out and look at all these economizers over all these roofs, and a large portion of them are not operating correctly. And so fault detection has become very, very prevalent on those to make sure that they're working right. But it hooks to chillers, it hooks to everything else so that we can see the operation of the system. Data centers, if you're a building department and you have a data center, you're going to want to have someone else help you with the review. But there is an ASHRAE 90.4 standard for data centers and the efficiency on it. Years ago, when my other son was working for SkyWest Airlines and he was their IT director, they didn't care about the efficiency on cooling of their data center. They just wanted to make sure it was cool. Well, as these data centers keep growing and growing, it's become a big deal. And he's at SpaceX now, and it's a huge deal because they have massive data centers at 6 locations across the country. And so it's a big deal to be efficient there. I'm just going to skip through this. If you want full-page slides so you can read these better, because you can't read your handout very good, this details what the fault detection system will tell you. We have, as we've had in the past, we'll take a break in about 10 to 15 minutes. We have a number of tables that you refer to for your HVAC equipment efficiencies. And they've added new tables. My battery just died. We've added new tables for dedicated outdoor air systems, water source heat pumps, variable refrigerant flow, heat pump, and heat reclaim chillers, and ceiling mounted computer rooms and commercial refrigerators and freezers. And so we've added a number of tables to the code. The first table in there is our air conditioners, our standard air conditioners, and I'm going to ask the code people in here, what's the typical distance between 2? The manufactured required distance between 2 condensing units. Anybody know? 24. That's the typical manufacturer. Some of them are 36. Do those have 24? 24 centimeters. This is, I even top it off. Has anybody seen the ads for air conditioner covers? Please, please, please don't, if anybody sees that ad, please don't buy one for your air conditioner. they're louvers, big louvers that you can hide the unsightly condensing unit, and it's just a bigger box. I don't know what the claim is, but this is actually a big deal. An air conditioner typically requires a minimum 12 inches on all sides. The service side needs to be open so you can get to it, but lots of times you can face it out. A lot of them will allow you to be 6 inches on one of the sides, but you have to have at least 12 on the others. But each unit needs 12 inches of free area so we can get air to it. This is a project that I was involved in as an expert witness, and their problems were not just that. In fact, that was minor compared to the other problems, but just be aware. I see so many air conditioners installed too close. So I'm just going to go through these tables real quick, and then we'll take a break. So the first one was condensing units, and we have an efficiency requirement. Be aware that effective January 1 of this year, we have new SEER, it's SER2. It's a new rating system for air conditioning efficiency, and all of these tables almost have new efficiency ratings in them. So what, I'm sorry?
Beginning when?
It became a federal standard the first of this year. So they're going to have SER2s instead of just SERs. So you need to look at the tables. And all these tables have a minimum efficiency. So what do you do as a plans examiner? When you get a set of plans, you go to the mechanical pages, you look for the efficiency rating in the tables, and it should be listed in there, and if it isn't, you need to ask for it to verify that it meets whatever the table in the IECC asks for. And it's very similar to ASHRAE. ASHRAE has the same thing. There's no difference. So condensing units, heat pumps, same thing, and it's also going to have COPs and HSPFs and all the other ratings they put on heat pumps. Water chilling packages, I call them all PTACs, but they're a whole bunch of different things. They're single package air conditioners and heat pumps. And it includes your standard motel unit.
Which as most call it mini split, am I right?
I'm sorry?
As most call it a mini split right there?
Actually, it's not a mini split because it's not split. A mini split has a small outdoor unit and a small indoor unit. You see what I'm saying? Yep. So these are all, this is a single package. The condenser and the evaporator are all in the same. The evaporator's inside and blowing the cool air, the condenser on the outside dumping the heat out, and reverse cycles for heat pump. Same thing here. It's a package unit. Now this is a split system. It's not a mini, but of course it's a warm air furnace. Our boilers. Heat rejection equipment. You're going to hear that word and read it a lot in the code. It's how we're rejecting heat out of our building. If we have a chiller, we're producing chilled water that we circulate to all the coils through the building, and then we are also sending the waste heat, or the heat that we grab from our spaces, to outside, and we're dumping them with a cooling tower. This is the same cooling tower that we can use for that free indirect cooling, because we have the pads that we get all saturated with water. We flow air through it. Evaporation is a cooling process. We can drop it 20 or 30 degrees, take that chilled, evaporatively chilled water in and circulate it through a separate coil, and we get indirect free cooling. All we're using is a little bit of pump and fan horsepower. Variable refrigerant flow. We have our outdoor unit and multiple heads on the inside. Again, we have our ratings there. This is a view down, and I don't know if, I'm going to guess that these can be set side by side, that the air just comes in the two ends. This is looking down from that slide I had at the first with the condensing units too close. But this is a bunch of variable refrigerant flow outdoor units and heat pumps. There's our computer room cooling systems, and lots of times These are set raised up on a floor, and sometimes they have a solid floor, blow the cool air into the floor, and then it comes up through the racks, or in this case, it blew out through the top and the return comes in the bottom. Basically, pool dehumidifiers. A pool dehumidifier is an air conditioning system. Here's the evaporator, the indoor section that gets cold. It gets cold. What does it do? It removes moisture. It dehumidifies. Well, what if we don't want to cool the space? We go back and we take and put a reheat coil, so we take some of that heat that we sucked out of the air so we could pull the moisture out, and we put the heat back into this reheat coil so that the net temperature change through the unit is 0. And then any excess heat that we have to reject, we reject outside. They work wonderfully in humid climates. It's silly for us to use them here because we're so dry. We can use energy recovery, heat recovery ventilators, and not burn all the electricity that it takes to run a compressor. But we have an MRE, and I can't remember what it is, but it's an efficiency rating for that in accordance with the test procedure. Dedicated outdoor air systems. These are becoming more and more popular. We're building all these tight multi-family buildings, and what do we have to do? We have to bring in some ventilation air, so we put in a dedicated outdoor air system, bring in fresh air from outside. We can heat and cool it, and then we dump a little bit into each unit. So we have some ventilation air into each space. Efficiency, the listings there. Dedicated outdoor air systems with heat recovery. Is everybody familiar with the term heat recovery ventilator? Be brave if you're not. You're not, Lon? Okay. Basically, a heat recovery ventilator is, and I think I might have a slide further on, but I'm just going to describe it real quick. My previous home, I had 2 heat recovery ventilators in it. And what they did is I ducted them to all the bathrooms. One did one end of the house, one did the other end of the house. And I could set them to run all the time, or I could put them on switches. And so each bathroom would exhaust about 50 CFM. And I'd have it just run 2 bathrooms on one end and the laundry room. And as it dumps 100 CFM or whatever it is to outside, I was going to take a break, wasn't I? I'll finish this comment. As I dump, let's say I'm dumping 100 CFM outside. What am I throwing away at the same time? I'm throwing away the heat or the cooling that I just spent money to produce. And then I'm bringing in air that's what? Either hot or cold that I'm going to have to reheat inside the space. Well, a heat recovery or energy recovery ventilator actually recovers some of that energy from our waste air to preheat the air we're bringing back in. So it goes through a heat exchanger. Air going outside, air coming from outside in, and we recover a lot of the energy, up to 80–85% of it.
So from a bathroom, even though it's like got all the moisture and whatever in it?
Yeah. Yeah.
The air never mixes, it's just the
Yeah.
cold that-
Yeah, the air doesn't mix. They never see each other. And I think I have another slide in here. They're pretty simple. In fact, go to YouTube and look up HRV, ERV. There's a ton of really cool graphics and stuff on it.
It's kind of like the radiator in your car. You never throw the coolant out.
They're just like passing each other.
Yeah, so
Yeah.
you take the air from outside, cool the coolant that cycles through your engine block.
Is that kind of like the recycling areas that you get the button on your car and you're using it?
Well, that means we're not bringing in outside air, and so we're just, this we're not recycling any air. We are ventilating and we're replacing. When we turn on an exhaust fan in a bathroom, what do? We exhaust air out, or in a kitchen, exhaust air out if it's vented outside, and then where does the air come to replace it? Wherever it can come in, right? That's standard basic mechanical ventilation. If we can recover some of that energy from that air we want to get rid of, we save a lot of money. And And then it's a balanced ventilation system. We're not relying on leakage through walls. If you build a building with ICFs, insulated concrete forms, that I was involved in a project down by the, what do you call the bees field, Smith's or? Smith's Ballpark. Soon to be. I'm excited because I live in South Jordan. Built a bunch of townhouses with ICFs. And they spent 2 years fighting leaks around the windows. And the windows weren't leaking, they were condensing because they didn't put a balanced ventilation system on this. Insulated concrete forms, ICFs, foam, concrete foam, how much air leaks through an ICF wall? 0. All their replacement air supposedly from their bath fans was to leak into the building. Well, no one runs the bath fan any more than they have to. Those buildings had to have, because they were so tight, they had to have balanced ventilation. You exhaust a certain amount and you bring a certain amount in. Because the relative humidity in those buildings was running at 70–75%. Because the stupid people would breathe in the building, they would shower in the building, they did all these things that added moisture to it. And we do the same thing in ours. And so ventilation, you know, I'm off the sidetrack, but
So it was raining inside the building instead of
it
outside.
was raining inside the building. Yep, that's what I was doing. Let's take a break. 10 minutes and then we'll get after it. Hopefully we get there the next hour.
Yeah, wake us up when you get there.
I'll throw something at you, Kyle. But you're adding to the conversation, so that's great. So dedicated outdoor air units, which are bringing in, the previous outdoor air units are just bringing in air. And we have to rely on exhaust fans or something to relieve the excess air. These actually relieve the excess air through a heat exchanger and recovers the energy from it. And they have efficiency requirements. Electrically operated water source heat pumps. And gentleman from Salt Lake City, I can't remember your name, we had a conversation at break on heat exchangers. We have air-to-air heat exchangers, we have water-to-air heat exchangers, we have water-to-water heat exchangers. And in this case, we have water-to-water heat exchanger down here, a water source. And what can the source be here? That can be a ground source where you put a loop in the ground. It could be a lake. It could be a non-consumptive well that we pull water out of the ground, run it through it, and put it back in. But there's a heat exchanger that is the condenser side, where we're rejecting heat in cooling mode. And then we have a fan and a coil up here, and that's a air-to-water heat exchanger, so that the chilled water off this goes up through there, and then heat pump mode, it just reverse cycles, and we pull the heat out of the ground and put it in to the space, rather than take the heat out of the space in the summer and put it into the ground. But it's two different exchangers. It's just what we're looking at. Chiller packages, heat pump and heat recovery chillers. A chiller, as I mentioned earlier, I think, chills water and sends it out through a building. You can move more BTUs in water than you can in air. And so when you get a big building, circulate hot water, circulate chilled water, and you can move BTUs in and out of the building a lot more effectively when you have long runs. You also can have some heat recovery built into your chillers. It's a little more complex. We won't go into it. If you want to talk about it, we can after, or you can send me an email. But they have some efficiency requirements there too. Seating mounted computer room air conditioners. Liebert makes units that you can just put right in your grid ceiling for a small computer room. And you typically duct outside the heat. Supplementary heat pumps. I don't think we want to waste any time on this one. Basically, heat pumps, I think everybody understands, a heat pump in the wintertime pulls heat from the cooler outside, brings it inside, or if it's a ground source, we pull it out of the ground, bring it inside, and it reverse cycles in the summertime. Well, in the wintertime, if it gets really cold, we might have a heat pump that can't keep up because we're trying to pull heat out of an already cold environment. Does that make sense? And so some heat pumps will have a supplementary heat. And if it's electric heat, which is basically big toaster strips, we don't want those on unless we absolutely have to. So what this requirement says is if the heat pump through refrigeration can keep up with the load, the strips have to be locked out so that we can't be wasteful in our energy usage. Again, this is one that I could meet with you more after. HVAC controls added optimized stop scheduling adjustment. Now in large buildings, and this isn't even a large building that we're looking at there, but if we have this 20-something story building downtown, but in a lot of these large buildings, obviously it saves them money to shut down for weekends. It saves a lot of money. And they shut them down at night too. And so you have programmed into them that everybody leaves at 5 o'clock, for instance. So at 5 o'clock, the system's shut down. Well, optimized stop scheduling looks at the building, looks how fast it cools down or how fast it cools up, depending on the season. And it looks at, well, it's 5 o'clock, but we know that no one's going to whine if we're 2 degrees colder or 2 degrees hotter at 5 o'clock. So we're going to shut it off a little bit earlier so we kind of coast into our setback or setup. It's an additional feature. HVAC controls for a number of years have had what we call adaptive intelligent controls. Earlier programmable thermostats, you set, we're going to bed at 10 o'clock, we're getting up, we're getting up at 6 o'clock. So you set those 2 times. Well, at 6 o'clock, you get up and it's still cold in the house, and so you say, well, I'm going to set it for 5 o'clock so that it's warm at 6 o'clock. Well, adaptive intelligent controls, and this is part of that, look at the house or the building and how long it took to cool off, and can predict how long it's going to take to heat back up. And so you set for 6 o'clock, and the thermostat makes the decision on when the heat needs to turn on, so you're at temperature at 6 o'clock. So it's all in the logic in the thermostat. It's pretty cool, and it's been out for a long time. But this is kind of doing a similar thing on the controls. And in fact, I've had people call me up and say, my heat didn't set down last night. Well, it was 10 below zero. It was that 1 in 20-year event where it got so cold that the thermostat said, I'm not turning down because we need to heat the house all night because it's using most of our capacity. We already talked about cooling towers a little bit. They're circulating water through a tower. We're cooling it off. We have some control changes where we want to shut down pumps and such when they're not in use. You get in a big building and you have so many pumps running and so many fans running and all this stuff, and they're wasting a lot of energy because sometimes we don't have any demand for a little bit, but it just sits and runs anyway. And as we get a little further on, you'll see that we have lots of additions to the code that we minimize pump operation and fan operation because pumps and fans use a lot of power. You no longer have to use economizers if you're using variable refrigerant flow systems. Demand-controlled ventilation. Anybody ever heard of demand-controlled ventilation? Jacqueline has, because she's heard me talk about it 4 or 5 times. I taught it to you here in this building when you're getting your degree, didn't I? How many people could we put in this room? Might even say someplace. 80? 52? It's bigger than 500 square feet. It has, we definitely have an occupancy listing or rating on this building that's higher than 15 people per 1,000 square feet. When the building's empty, how much ventilation air do we need in it? How much fresh air do we need to come in from outside? Really zero, right? Well, no one's in it. What about when we fill it up? We need so much, 7.5 CFM per person, plus a little bit for the square footage. So we need a certain amount of CFM. You have churches all over this valley. And Kyle knows where I live, and I have a neighbor 2 doors down that plays the organ at the church down around the corner. We call it the Red Building, you remember that? And she goes and practices. Chapel has an occupancy rating of 300 or something like that. And Sue goes over to practice the organ during the week, and one person in there. How much ventilation air do we need? Almost none. So how do we save money on ventilation? Do we count the number of people that are going to be in there? That's actually what we do. How do we count them? You want to guess, Lon?
Like an A or,
Huh?
like it's, for example, one day it's not occupied, but the next day it is.
Well, we could program it in. How about we put a CO2 sensor in the room? Because what do? We breathe. So we put a CO2 sensor on it, and it modulates the ventilation air based on how many people are in there. Now we might have a minimum ventilation air where we're bringing just a little bit of fresh air in there just so the building doesn't get stagnant, but we modulate that. And that makes a huge difference on auditorium type assembly occupancies. And they've actually dropped it down. It was 25 people per 1,000 square feet. It's dropped down to 15 people per 1,000 feet. It's simple. It's built into most rooftop units now. A building like this that has a BMS control, it just has to be programmed in, and the sensors, adjust the VAV box for this room. And there's some other requirements there that we're going to skip through. Parking garages, the typical parking garage over the years has had a carbon monoxide sensor. When carbon monoxide gets to a certain level, the fans turn on and it just roars away and it exhausts all the carbon monoxide. And then we've gone to staging on it where they go from a high speed to a medium speed and stuff. Well, it's taken a little bit further now, and it's actually starting to modulate and slowing the fan down and speeding the fan up and reduce the you didn't have to put the fancy controls on it until you hit 22,500 square CFM, It's dropped down to 8,000 CFM. And they also detect nitrogen dioxide, which you have more of out of diesel, and so it detects the diesel contaminants too. Here's an energy recovery ventilator, and it's hard to see, but you have 4 ducts to it. Exhaust from inside goes through this heat exchanger, and you can't see the back side of it. There's 2 fans. So we have airflow going this way and then airflow going this way. So outside air coming in and that way, inside air going out. And they are required on almost all apartments in our area if we have a high ventilation load, which is kind of unlikely. Unless they're putting hot tubs or spas in them, it's not going to be triggered. Here we go. Here we have a control thing. But it's HVAC control. But it has lighting on it.
They still interrupt.
And they're usually the same system. Hotel guest room temperature and ventilation controls. They've clarified the operating modes. Reduce occupancy sensor shut off from 30 minutes to 20 minutes. Basically, this one still has some problems. I stayed in a hotel in January up in Seattle, and when I checked in, my wife and I, they gave us 3 keys, you know, the cards.
She just kept going in there.
They said the third one is to stick in the thing inside the room and you just leave it there. So what it
Here's
did,
the interesting thing about that, because when we asked that when that first came up, way back in 2013 code cycle and certain things when the key card first came, and the hotels actually thought it would be a great idea because believe it or not, the single biggest thing that they found they were saving money on, the hotels found that was when they put a little piece of paper up in the bathroom that said, if you want to reuse your towels, hang them up. And in their mind, they were saving a tremendous amount of laundry by people hanging up their towels. And in their mind, they thought that their occupants would be okay with simply pulling a card and saving energy. But it's been all over the place with, like you said, a lot of people, they just give them an extra card to stick in.
yeah. Yeah, and you know what? I think what it really is we need to educate people. And they just need to, I think they just need to put a little sign by it that says your lights and air conditioning will work when you put the card in.
Well, some of the hotels actually have at the front entryway where you check in, they have one of the key card holders right there, and they'll show you put it in here. Put one of your key cards in here while you're in the room.
Yeah, it would save them money. There's no question about it. And I didn't leave it in there. I just,
Your wife did.
no, we just set it. In fact, it was right by, we had an extended stay room, and so there was a refrigerator real close by. And so we just set it on top of the fridge. But there's systems that are tied in with the reservation system, and they turn on 20 minutes before, check-in time, or when you do check in, it automatically kicks on, and then they have occupancy sensors. But it is an effort, and you think about it, some big hotels really pay some huge utility bills, and I think they would be all over it. And I'm sure they do save the money because hanging up the towel does save a lot of laundry. But anyway, this is on the HVAC side, but you notice for my picture that we have all the lighting and everything else. It's all tied and integrated into it. Fan array. This is a new definition in the code. Multiple fans in parallel between 2 plenum sections in an air distribution system. This is out of Facebook. And you can see down there, I was halfway down, so there's a little hallway between, so it's not 1,200 feet long altogether. It's about 600 feet with a separation in it. So you can see over here, this is under construction. This is where they're going to pull in fresh air. There's a big filter rack that goes there. And then these fans suck in air from outside. And then here they are building their evap cooler sections. In between they had dampers so you could do some bypassing and pressure control and such. But we have 6 fans, and they're about 3 foot in diameter each. And then they run all the way down. And these fans are substantially more efficient than a great big blower wheel. And the other thing with those great big blower wheels is if they're the slightest bit out of balance, they shake the hell out of the whole building. They're horrible. But this is a fan array. It's a whole set of fans. It's just exactly what it says. Oops. That's a big cooler, isn't it? Big evap cooler. So big evap coolers, the whole row of them there. This is from the other side. And they also have dampers that open when we don't need to go through the cooler pad. This is a little bit better view. That one's a little bit longer. That's a lot of fans. And if you can save money on the power for each one of those fans, you saved a lot of money. Reduce the energy. An embedded fan. And the reason we have these, I'm going over these definitions, is we have a lot of fan requirements added, and I don't know if you've seen them yet, Kyle, in the 21 code. All the fan efficiency, a lot of new efficiency. There's even a new standard. But they say specifically does not apply in some cases to embedded fans. And this is an embedded fan. It's part of what? It's part of the equipment. It's part of my garage unit heater is what it is. It's the embedded fan. Now, are you checking my gas line and stuff, Lon? Do I have the sediment trap?
Yeah.
Okay, just checking. Fan Energy Index, this is a new rating system for the efficiency of the fan. And there's a white paper you can download if you want to understand that whole thing. Fan nameplate electrical power, nominal electrical input power rated, power rated stamped on a fan assembly nameplate. These are the exhaust fans at Facebook that suck the air out and blow the exhaust out of the building after it's come in, gone through everything, gone through the server racks and everything, and it's on its way outside. And so they have an array of supply fans, and these are the array of exhaust fans. And notice they're both axial fans that are more efficient. Fan efficiency shall have a fan index not less than 1 at design point. I read up on what that means. I don't know exactly, but I can't remember exactly, but what we need to do is if we're reviewing one, we need to verify that the fans that they're using meet that efficiency. And here's all the exceptions. I'm not going to read through them all, but you know, there's a couple. Explosive atmospheres, moving gases above 425. There's some obvious exclusions. Okay, there we go. A better view of a heat recovery ventilator down there, or energy recovery ventilator. The air going through this direction does not mix at all with the air going this direction. A good way I can describe this is sometimes this heat exchanger in here looks like, and I don't think I talked to you about it at break, I talked with him, kind of looks like plastic cardboard, where you have all the little passages run through it, and you cut a bunch of squares and you stack them on top of each other, rotating each one 90 degrees to the other one. And guess what? Every other one, the air will go through this way, and the other ones will go through this way. So the air doesn't mix, but we have the ability to pick up heat and transfer heat based on the temperature difference between the two air streams. Clear now, huh? It's better. You know how to go to YouTube?
Yeah.
HRV or ERV?
So you have a vessel that's thermally conductive, you pass the air through it, so that all the heat goes into whatever vessel you're passing it through. And then you have something adjacent to that, you're passing the air through that's, you know, thermally conductive between those two vessels. And so you get the heat going between those two vessels, but the vessels themselves don't mix.
Yeah, they're isolated. The electrical side of the HVAC, no, the electrical side, HVAC and electrical, whatever, of the operable control. The first one is in the envelope. We have an opening in the envelope. The second section we're talking about is what the controls do. And again, if the outdoor temperature is below 90 or above 55, because you're not going to be opening it if it's above, you know, beyond those conditions. Refrigeration equipment performance. You code officials will run into this. How many people, their dream is opening a restaurant, and so they mortgage their house and everything, and they open some little restaurant. I probably did 10 of them out in Magna when I worked for the county. And so they buy a bunch of used equipment. And you buy and use walk-in boxes and stuff like that don't have any ratings on it. If you want to talk to me after, I'll give you some ideas on how you can maybe allow them to use some of that stuff. But it's supposed to, all your refrigeration uses a huge amount of power. You're supposed to ensure that the equipment is on the schedules and it meets it. Large surface water heating efficiency, if you use more than a million BTUs per hour of heating water, you have to be 92% efficient on your hot water heating. Heated hot water supplies. The question is, Lori, have you ever been to code hearings? No. Have you, Lon? They're in a big convention hotel, right? Big rooms, lots of people. Maybe you've been to something similar, or conventions, you've been to conventions and such. And they'll have these huge meeting rooms, and then of course on the outside there you have huge restrooms, right? How often do you ever get warm water when you go to wash your hands? Pretty much zero, isn't that our experience? And the reason is because of the stupid way they've designed the plumbing systems for them. And then we put these little faucets on there that don't move any water, and so you never clear the hot water. So 2 code cycles ago, this was put in the code, and we miss it all the time. And this is for public buildings. Gary Klein, and I don't remember who he works for, but he's a consultant on plumbing systems. He put in a table that identifies how many ounces of water is in a foot of all these various sizes of pipes. And the reason being is that he is saying that we need to look at how close we are to the source and what size the pipe is so that we have a reasonable chance that we're going to get some warm water. Well, what's the source on a big hotel? How far are we from the source? Well, the water heater's clear down in the basement. By code, the source is, if we have a recirculation loop, where do you hook onto the recirculation loop? Because the recirculation loop's insulated and that's your source. And so you can go either pipe length or pipe volume. You don't need to get your head wrapped around this. You can look at it after. The intent is trying to make sure we need just the minimum amount of volume to get hot water to the faucet. So I made a little sketch, and I made this because the plumber called me pissed off because he had to repipe a system. Here's a typical system. You have a 2-inch line running around the building, and there's a tees off and it comes down with a piece of 1 inch, and the 1 inch runs over to here, and we have like 7 labs on here. It goes 1 inch to here, then it reduces to 3/4, then each of these has a 1/2 inch stub coming out. That looks like a reasonable configuration, doesn't it? Then I have option 2 that I drew up, and this is what the code wants us to do. That you go over and you run the 2-inch down, and then you run it back up, and then you can run your little stubs out. And there's even a company that makes a little T-fitting that you can put up here, so you just run a small loop down and around to accomplish the same thing rather than the whole thing. But let's look at the calculations. If I use our volume table and I do a calculation, and I'm not going to go through it all because of time, but if we look back real quick, we have A to B, and then we have this of 1-inch pipe. So 1-inch pipe, we have 10 feet, plus 2.5, plus 2.5, we have 15 feet. 1-inch pipe, 5 fluid ounces per foot. So we have 75 fluid ounces of water in the 1-inch section. And I'm looking how much it takes to get to the far lab. Then we have 3/4 inch pipe. We have 7.5 feet and 22 fluid ounces. And then we have the 1/2 inch stub coming out, 6 fluid ounces for a total of 103.5 fluid ounces, almost a gallon of water to the furthest fixture, which is 0.8 gallons of water that we have to flush through the system before we're going to get water, hot water. How much water is coming out of that little thing that you're waving your hands at?
Not very much.
A meter lab is 0.25 gallons per metering cycle, and other than metering is 0.5. That's the minimum flow rates. And so basically, if we take the 0.5, the better of them, 0.81 gallons divided by the 0.5 gallons per minute, it's 162 minutes or 97 seconds. So if it's metered with the waving, double that number. Is anybody going to stand there for 3 minutes waving your hands trying to get? No. And even if they're full use, everybody's in there all the time, you're never going to get any hot water. So what's the moral of the story?
Short length from the hot water.
Short length or, and well, I talked to Jeremiah, my oldest, and he has some big buildings downtown that he's over and around the western United States. They're getting rid of those great big water heaters, 200-gallon water heaters in the basement with 2-inch pipe, recirc pumps that use all kinds of power, pumping water all the way around, and they're putting little at-source water heaters under all the, underneath the labs.
Didn't the code, the uniform building code have that in there once after so many feet? Have that there?
Yeah, yeah. I mean, it's only logical, isn't it?
So much more sense.
Yeah. And they say, well, electric water heating's expensive. How much water are we heating, for heaven's sakes?
How much are you using that recirc pump?
Yeah.
How much power is?
How much power is going into just the pump motor, right?
It's, yeah, it's run 24/7, it's running 24/7.
Even if it's on a time clock, it's just a huge amount of energy that's being wasted in those. You slap a little one underneath, whether you can size it for how many you have under there. Electrical engineer, am I flawed in my thinking?
Well, I was just thinking hard water. You have the hard water requirement for the Insta-Hots and the soft water.
Yeah, the soft water. Yeah. Obviously something to think about. But even if you replace the thing every few years, it's cheap compared to what you pay for. How big's that pump? 5 horse? Depending on outside the
And then
building.
you actually get hot water, imagine.
And you get hot water. You can actually wash your hands with warm water. And you save a bunch of money. Here's our additional efficiency requirements that I already went through real quick. I think we're going to move on and talk a little bit more deeply. If it's a tenant improvement, you need to achieve 5 points instead of 10. Achieving all 10 within the envelope is pretty hard. It's going to require some cooperation and teamwork between different design professionals. Sorry, Kyle, you're going to have to talk to the ME.
I just know reducing my lighting, gets you 9 out of the 10.
Yeah.
Gets most of it there.
Yeah.
Stick with that. We're good with that.
That's the one I control, so that's one that
Yeah.
always gets me on there, so.
And well, lighting power density has been an easy one for years. The code's catching up with it. When LED was really expensive and stuff, and then all of a sudden it became more affordable, I was getting comm checks that came in that were, lighting comm checks were passing by 50% because they put LED light in and the code hadn't recognized, the full value and all that. And
Young deal with all the interior decorators, they're still putting in incandescents, and I'm like, this matt's.
yeah. Yeah. Anyway, those are the occupancy tables. I think we already touched on them. Warmer climates, greater credit for cooling. Colder climates, greater credit for efficiency. Here's the table we already looked at. Notice in 2A, which we are not, but this is in, it's going to be on the Gulf Coast. They don't do any heating, do they? So they don't get anything for it. But they can pick up 10 points for cooling right there real quick. They're not going to get anything for this because it's a B, just like the others. Here's the R's. So this is a different table, and we're going to see different R occupancies. Sorry, guys. You're not going to get anything for your enhanced digital lighting controls, because you really don't have an application in an apartment. Efficient fossil fuel water heating. Big credit depending on where you are. Reduce air infiltration. 6A, 13. I have to think about that one. That's tightening up the envelope. Oh, it's because it's cold. Cold and humid. Yeah, that's it. 6, or is that 6B? No, it's 6A. A is humid, but if it's cold, also dealing with humidity. Commissioning, and we've talked briefly about this before. Commissioning is not triggered unless the total mechanical equipment capacity is over 40 tons, 480,000 BTUs, cooling capacity, and 600,000 BTUs combined service water heating and space heating. And so unless you have that kind of heating capacity, you don't have to commission. Now, what's the big thing on this? This is for the design team to understand, is they don't want to oversize their equipment, because oversizing their equipment is going to push them into commissioning the building. And that's been in the code, it's not a change. Look at that, we got to lighting. High efficacy is defined as fluorescent LED T8 or smaller, linear fluorescent or other lamps with efficacy not less than 65 lumens per watt, or luminaires with an efficacy of not less than 45 lumens per watt. So there's our definition. Sleeping units, 90% of the lamps must meet that efficacy requirements. Lighting controls, lighting reduction controls are added, or modified. Daylight responsive controls and specific application controls have added some new controls. So basically our lighting systems have occupancy sensor controls. You walk in, they turn on, or you leave, they turn off after so long. Time switch controls. We're programmed at certain times. Lighting reduction controls. You get some light through the windows, you reduce the lights. Maybe you've walked through a big box store, the lights, you notice the lights just changed. Well, enough light was coming through, it was sensed, and it reduced the lights. It might even turn them off almost.
So what's the difference between light reduction controls and daylight responsive? Isn't the light reduction just like a dimmer?
Yeah, typically dimming
Like a
on your
manual.
own, like an end user dimming, being able to control it.
Yeah.
One of the occupancy options is you have it automatically come on to 50% when you walk in the room. It's supposed to be either manual on or 50% on. Corridors and bathrooms, things like that can come on 100%, but nothing should be 100% on. So that's what the lighting reduction is.
Okay.
Is so that if you need the light, you can go up to 100%, but
Manually?
yeah, everything should be 50% for like the cleaning crew that goes through and doesn't need all the lights to be on 100%. So you have enough for the task that you have at hand. They want you to assume that you only need half of the light to do your task, and you'll go turn lights up if you need it.
Yeah. And it's become very popular also because, don't we, if we're looking at a computer sometimes, we want the light a little bit lower?
Reduce.
I do. I put a dimmer in my office at home so I vary it depending on what I'm doing. If I'm working on papers, detail stuff, I have brighter light than when I'm on my computer. And then we have specific application controls, and we'll touch on some of these. And I appreciate having you guys here, because please feel free to just jump in, because you guys spend your whole day in it. And,
Yeah.
occupancy sensors are required in all these different spaces. I don't know if I have slides in here, but there's a couple places that we don't want automatically shutting off lights, and that's in corridors and stuff like that. But we can dim them in some of those places. And that's why the corridors are in there now. Corridors, stairways, restrooms, and stuff are exceptions to full auto and on. Full auto controls with no manual allowed in these places. I remember when I went to Granite High School a long, long time ago, that it was the funny thing is when there was just a couple of guys left in the locker room, you headed out, you shut the lights off.
Shut the lights off, right?
Yeah. So there's places we don't want to endanger safety or security. Warehouses, and these are new, aren't they, Kyle?
Well, it showed up last time in 2008.
18.
Yeah,
I think they changed,
The timeouts then reduce.
that's changed. Auto renews by within 20 minutes, was it?
On that, it was 30.
Okay. And so there's a couple of ways you can treat these buildings. If they're not turned off by occupancy sensors, they can be turned off by a time switch too. The building's not occupied anymore, we shut them off. And really, do we need that bright a light in a warehouse? Not really.
depends on how small your label is.
Yeah. And how old your eyeballs are. You'll know when your
Oh,
hair
I'm
changes
there.
color.
I'm there.
When you're,
Landon's the young one.
you both look pretty young. Please.
Brent, in regards to NEC 2020 comparison to the IECC for this, is there something that's trumpeting the other, or is this coming from the NEC?
I don't think NEC really has a lot of mandatory lighting controls in it, does it?
The only place that it really overlaps is in electrical rooms where it says that the electrical room cannot be automatic only. You have to be able to turn it on and it stays on while the guy's in there working. So that's the only place that really gets into lighting control.
I'm just kind of wondering how the IECC would compare it, because you got in the view aspect, you got NEC and IECC, so we're trying to compare the two.
Kind of completely different scopes.
Yeah, the NEC is really focusing on the safety aspects and the specific, I mean, it's, well, there's obviously hundreds of sections in there, but the NEC really doesn't, just like the IMC, really doesn't bother itself with, you have to use this type of control, you have to, you have to do this or that, or it doesn't have efficiencies in it. It mentions duct insulation a little bit, but what does it refer to? It refers to the energy code. In fact, that's something that we ran into a problem on a fairly big space. It was a mechanics shop that they wanted to put hydronic heating in the floor for the mechanics, because they bring in, well, it was a truck shop, and all the wet and cold and everything, and they wanted the floor to dry and such. And the IMC used to have the requirement that if you had radiant tubing in the floor slab, you had to put R5 underneath it. And that was only insulation listed in the IMC. And the mechanical engineer missed it. And they had the rebar down and the tubing all tied and no insulation underneath it, which is required for slab on grade. And it turned out to be a real big mess, finger pointing and everything. And so we actually fixed the code and got the insulation requirement out of it and put it in the energy code where it belongs. And so I really think it's best that we don't have these types of requirements in the NEC,
One of
This-
the- one of
go
the
ahead,
things that
please.
some of the, pretty much most of the energy codes, the big three, IECC, ASHRAE 90.1, Title 24, have adopted this language, not more than 50% of the full power. Some people have taken that to mean to turn all the way off. What we've seen across the country now is a lot of the fire marshals, as they're going out and doing they're walking the building, they're saying, no, you cannot turn these off. You have to maintain minimum foot candle within the building while the building is occupied. So this Title 24, actually in the 2022 code cycle, the latest, they actually added wording that at no time shall it be below, the minimum foot candle level. So
During
that's something-
occupancy.
During occupancy. So when the building is occupied.
Yeah.
Technically, that means during normal business hours, after
Right.
hours they can, but a lot of the, code official, the fire marshals, when they're walking it for safety, they're going, wait a minute, when you're turning everything off, there's, that egress path has to be lit, minimum foot candle on the building is, is occupied. So this wording, not more than 50%, some see it as a loophole just to turn them all the way off, but it's caused some challenges on a lot of projects.
These are things we catch all the time. We get it in the code and all of a sudden, before it's even published, we go, oh crap, this isn't right. And we have, what are our choices? We can fix it at the state level if we want to, or we can fix it at the next code cycle. But when's the next code cycle? But by the time we find it, we're usually past.
Well, here's the funny thing, in a code cycle, for instance, the 2025 code cycle is already this year. By the end of this year, we will have the majority of the 2025 code cycle done for ASHRAE and Title 24, okay? Already this far ahead of time. It's hilarious. In California, Title 24 just came out with all kinds of delineations on linear fluorescent, and you can't even sell linear fluorescent in California anymore when the code came out. So so you try to stay ahead of it and pick it up. But a lot of the municipalities can actually have what's called reach codes as well. When they find something like this within the code, they can actually clarify within their
Yeah.
municipality how they're gonna handle it, as long as it's published somewhere on their website.
We have the challenge in our state that we can't do that. Park City would love to have a more efficient energy code. There's other communities that would like to have more, but you can't do it unless it's approved by the state legislature.
I thought you could do it as long as you did it as a local amendment.
You could do a local amendment, but it has to be approved by the legislature and become part of the State Fire and Construction Codes Act.
They have to adapt it as a state,
Well, basically,
at the state level.
I'm going to say it again, I've said it before. Basically, there's a Beatles song, it's called The Fool on the Hill. Basically, they have to approve it. And they won't approve something that adds cost to a residential home. A commercial building, they probably won't care because they don't have a lobby that worries about commercial energy efficiency. We don't have any amendments. We have 0 amendments to the 2021 commercial energy provisions in Utah. None.
So places like Farmington used to have like exemptions for like the windows above certain levels for the speed of the wind. Like
Yep.
that was one provision that the particular area had,
Yep.
right? So there are approved provisions in
There,
certain
they
areas.
are, and Farmington has them, there's several that have been approved, that are local. And there's even some that they begrudgingly approved, like fire sprinklers in the wildland interface, areas, FCOS areas and stuff like that. But yeah, we can't, Colorado, you can do whatever you want. Some places don't have any code and some places have very, very stringent code. Parker, Colorado, Gil Rossmiller, a friend of mine, when he was building official there, he was, we're going to do this, we're going to do HRB, we're going to do all these things, and that's what they did. Moab would love to be more efficient. You know, Moab has a unique population down there. I love teaching down there because they're laid back and everybody loves energy code classes down there and they want to go beyond. So it's our market and where we're at.
Well, you know that Magnet and Unincorporated has an overpressure ordinance, right? So how
Yep.
come that doesn't have to be approved by the state?
Because it isn't part of the building code, I don't think.
Yeah, because your building has to be designed for,
It's probably approved then.
So that's where it comes into play, local code is
Yeah.
technically the ordinances that are stated by that.
We have ordinances, but ordinances can't change the building code itself. If it's an amendment to the building code, it has to go through the legislature. If it's an ordinance that doesn't change the building code, then the city can do what they want. Like setbacks and all those types of things. Those aren't building code.
We're not following all
it's like maximum window size panes, right?
Well, egress is building code.
Well, here's the thing there, not to take it off of this, but like, Salt Lake City has a existing code, existing building code.
Right.
We have IRC, we have IECC, but some people want to use the Salt Lake City existing building code, 1850 ordinance.
It's a housing code. It does not amend the IRC or the IBC. It's an additional housing code. You have a housing department. No one else has it in Salt Lake City. You have housing inspectors. We don't. No one else has them. Yeah. You brought up a great point that got it started here, but, you know, the unintended consequences sometimes, and sometimes it's just confusion. I think it's fairly clear, but maybe it needs something added, and I'd have to reread it to see if they clarified that it doesn't go, well, this exception, corridors with less than 2-foot candles, illumination on the floor at the darkest point with all lights on. They could be too dark. Time switch controls. There's a change. Luminaires required to have specific application controls. Daylight responsive controls is what it boils down to. You guys chime in if you have anything here. I'm moving through because I still got quite a few things I wanted to touch on. Time clocks, or time switch controls. This ties in what you were just talking about. We can do this dimming and stuff, but we want to maintain a certain amount of light. But at the time that everybody goes home, everything goes off. Now, the small buildings, we have some resistance from small commercial builders. They say, oh, well, I hate all this stuff. Well, on the small buildings, as I understand it, you put in occupancy sensors, and a lot of this stuff just automatically is taken care of.
20 minutes.
You know, 20 minutes, if no one's in there, they're off. It's not adding a huge big burden, and those things aren't that expensive. Again, my son talks about what they used to pay for, and maybe you've been at electrical engineering for a long time. What did it used to cost to put some type of astronomical control on your lights before we?
Probably $300, $400, I get the wall box, and it's like $50 or less.
Yeah.
Yeah.
And time clocks and all these things and having to reprogram them, and, you know, the digital controls and, you know, the controls that we have today are just great, and they make it so easy. And, you know, it's like lighting. You guys know Jody Good?
Yes, sir.
He's a sharp guy. He knows lighting. I had a builder that was just irate, pissed off, just beyond belief, because I made him do a lighting comm check, and he failed because he wanted to use garbage lights, and so I just turned him over to Jody, and Jody set him straight real quick that It's so easy now with our lighting technology and the controls you guys have, and they don't break the bank, you know, they're pretty amazing. Because all of this stuff can be done easily. And we just talked about not less than 50%. Reasonable uniform pattern. Lighting reduction control options, continuous dimming of all luminaires from full down to 20%. Switch all luminaires to reduce output not less than 30%, not more than 70% of full power, and switch alternate. And this is for reducing where you have a whole bunch of, like you have in here. How do you reduce?
One on, two on.
Yeah, one off, one on. Do we do that anymore, or do we just dim them?
Just dim.
Checkerboard, no, it's,
Depends on if they're reusing old fixtures.
Fluorescent tubes,
Yeah.
yeah. Yeah, well, and that's the way it was for a long time. Now, what I wish they would put in the code, and all you electrical guys, for classrooms, I want these to shut off.
Good design would have that already, but it's not in the code.
We need to work on that one, don't we? What do you think?
It's a- no, it's a- it's- it is-
These daylight harvesting,
Yeah.
and then, you know, that overlaps where the presenter wants to dim, and then you've got the back of the classroom where the kids are taking notes, but that overlaps with the daylight harvesting too.
Yeah.
So it's like, you have all these zones and we have different needs, but they all overlap.
I'm being selfish.
no, I mean, I understand what you're saying. The thing is, from a code, on a code panel, as that would be discussed, that would be discussed as a lighting design criteria versus energy code criteria. The pushback on making that a requirement of the code, because I've sat in those things, is if you have windows over here, okay, and IECC, you still only have the primary zone, right? ASHRAE, you have primary, ASHRAE in Title 24, you have primary and secondary, okay? And the problem is now when you do that, you're adding the, you can probably hear me on that.
Problem.
The, what you're adding is you add an additional zone to the control of this one light, this one or two lights here, because if you're switching that separately, because as you pointed out, you have the daylights going down this way, and if it's ASHRAE and Title 24, you're adding two more zones, you know, for those two fixtures to do that. So, and that's why from the energy code doesn't step into the lighting design aspects of what you're trying to find. I understand totally what you're talking about, and all of the code panels have really been trying to get IES back into. They used to be really involved in the code sections to bring up all of these lighting design challenges as the code is being put together, and it just, you know, it's hard to get them back in the game, but that's a big,
Yeah.
Because it makes sense during the day when the light's coming in through the window, but when you're teaching at night, your control's perpendicular to what you need it to be,
well,
you know?
and it doesn't make, that's one of the other code problems that we're having a lot of problems with is, none of the codes address the lighting on the north side of the building. It still has the exact same, daylight harvesting challenges, okay, but it's a huge challenge when you get on the north side of the building when all of when the sun's coming across the northern hemisphere, when it's coming across.
Or even when you have an east that meets the south, you know, or a west that meets the south.
So, if I understand what you're saying correctly, is Kyle needs to design it for me and for you.
Yes.
Is that what we're saying, Kyle?
Just gotta turn a blind eye to the energy code if I want to design a functional.
Either that or add the additional controls to break those small sections up into
Yeah.
individual, because what you're doing, I mean, you're adding a whole nother zone.
Yeah, I look at it as a scene rather than
I like to put photos in my presentation. This probably has the least number of anything I've done in a long time. I like to put photos in them. And when the lighting's bad or bright, you can't see the detail in the photos. And people like photos in slides. I'll be honest with you, and I understand completely, everybody sitting out there looking at that slide is, oh, yeah, there's not a photo in there, you know? So it makes it hard. And I think actually, and in fact, I'm pretty sure that we do have primary and secondary in the 21 code now.
21
Yeah.
sounds right.
Yeah.
Yep.
In fact, I think I have a slide or two in here. Be trying to keep up with, because I worked on the 24 and I worked on the 21 and I worked on the, you know, and it's up there somewhere.
Right there.
Yeah, there we go. So some of you out there probably aren't familiar with what we were just talking about, but this will bring it together. So we're talking about daylight zones. Lon, you're sitting in a daylight zone, right? Because of the window. And I'm really not in the daylight zone because I'm beyond the 2 feet edge of the window. You guys really aren't in the daylight zone. And we're not going to spend a lot of time me making complaints about the height of the window and what do you do for the spaces in between and everything, because I think there's some flaws there in the code. But you see the primary intent. You have a primary side lit zone where, of course, it's going to be brighter, and then your secondary, it's going to be a little less. And we talk about the code, you know, has examples of here of full height walls, and then on other slides, maybe I have them in there, it talks about shorter walls. But the daylight zone typically goes a foot on either, 2 feet on either side. Is that right?
Yes, 2 feet on either side, and then the height of the fenestration.
And then the height of the fenestration, yep.
Right down.
So what, you just mentioned this. New in this code is the primary and the secondary have individual control, correct? Dim lights continuously from full light output to 15% of full light output or lower. Controls configured to completely shut off all controlled lights. So those are kind of the changes.
And one thing that I've seen on some designs is when they say that control in different areas, an engineer or a designer may draw 2 switches for those areas. But it's not talking about manual control, it's talking about control to the system. It's gonna dim them automatically. So that's one thing to look for.
This is, and you guys are code officials. Help me out on this. How do I approach this trying to teach you guys on it? How do we, and I'm going to ask you guys too, so I'm just going to throw this out to the group. We have a room like this. Someone comes to me on plan review. How would you approach, and maybe bring the microphone over here. You see this room, the way it's configured. What should the code official require in a room like this that has 8 feet between windows?
They need to draw the actual zones on the plan.
Yeah, the code does require, I mean, in a lot of the codes, they do require for the daylight zones to be drawn on the plan, usually as a dotted line. But one of the things that we were discussing in between also is, one of the things a lot of the municipalities now are asking for more of is sequence of operation actually on the plans, where it actually describes how the controls are to be set up. Because the challenge, you can show a bunch of components on a plan, okay, and they can be installed in the room, but if they're not set up per a sequence of operation that meets the energy code requirements, then it's, ASHRAE does a much better job of this. ASHRAE actually has each individual section, room type, and then it has what controls are required and what are not required, okay? And then it'll even give you the option, you have to pick one of 2. Are you gonna do partial on, or are you gonna do manual on, vacancy sensors? And then it goes in, so it breaks it down a lot better, but that's the challenge of, now this room, yeah, if you're showing the daylight zones, one of the things, go back to your slide. So if you note, there is a, between the two fixtures and over to the side, there's a non-daylight zone. What we see in a lot of applications is they just, even if there's a light that falls within those dark spots, they're controlling them as a continuous row of fixtures, okay? The other big problem that we're having is, Title 24 is the first code that actually addressed it now, is you'll have in this room you got 2x4 troffers, but more and more what we're seeing is linear LEDs, okay, that would basically start over here and they'd go 16 feet. It's a continuous fixture with a single driver, okay? And they'll say, oh, we'll do a better job, we'll control that whole fixture as if it's in the primary zone, we're gonna save more energy. Well, the problem with that is after the first couple months, they disconnect the photocell, because as you transition between the primary to the secondary and then to the non, each of those transitions, your light from the outside drops off about 20%. So by the time you're all the way in the non-daylight zone, you're 40% lower, but you got a light that's dimmed down for the primary zone.
Well,
Okay.
why would you even allow the lights to go this way, they have to go this way? So that
Well, but
they
in
could
this room, you've got, this would be if you're using linear LEDs in this room, if you're gonna use a single fixture, again, cost implications, if you use a single fixture with a single driver full length, you're gonna save money, right? But this room has daylight zones across the back and coming this. So either way, you're gonna have that fixture if you're using a continuous linear drive. What Title 24 did finally is it acknowledged the fact that these fixtures are available in 4-foot increments or less. So they're basically saying you have to at least break it somewhere between the transition of the zones.
So this back wall,
Okay.
spill your coffee? Carl,
I have the effect on.
Carl, can you switch the camera over to? So this back wall, we do have a dark corner and a dark corner and a little dark spot in between, right?
Yes.
And so you would,
You would literally, that fixture that falls right up above where the camera is right there, okay, that would be a separate zone. You would actually have on that back wall, if you look at it, if it was extended a little bit further over, because technically that first row of fixtures on the first side and that other row of fixtures on this side is almost 2 feet away. So you would have along that back wall there, if you'd have a primary daylight zone, you'd have 1, 2, 3, 4, 5 zones in the primary zone. To do it
The guy who's
properly.
selling lighting control.
I mean, to do it, no. I mean,
oh, that's why I bring
okay,
it.
So
I know
this is the
that.
thing, this is the letter of the law, we're talking about the letter of the law, right?
Right.
So, that's the challenge. Now, the other thing that I always like to try to, as we're designing and as we're talking about the code, is it's really key to understand the intent behind the code. Because if you understand the intent, then you could basically say, okay, we're gonna allow the 2 window zones, the 2 daylight zones to actually be controlled on with the same sensor and the same control, you know, and what we'll do is we'll put the fixture on that side, the middle, and the other on its own zone. So now you've taken that and you've changed it to 2 zones, okay? The ones that are subject to the window, because your side light isn't gonna change that much. Okay, so understanding the intent behind the code would allow a plans official or someone else that's functionally testing it to making sure the design of it is correct. And that's the key. Oftentimes people are so focused in on the letter of the law, so to speak, that they're not paying attention to the intent and really what's the ramifications. So what would normally take, my kid's in the Air Force, I don't have to pay for his college anymore, so I'm okay helping on the controls. But that's the thing, I could take that and what appears to be 5 zones should be able to be designed as simply 2 zones, and then that fixture, you know, and simply you would show it you know, by the zoning, you put an A, an A, an A, a B, okay, or a B, A, and then the second, A1, you know, B1, I'm sorry, A1, B1, and then come into the secondary zone, B1, C1, or something like that, you know what I mean? So that would, how I would design it. Now, the challenge is now you come around this way, and again, you have the same challenge.
The same thing.
Technically, that middle road right there, okay, is also on a separate zone. It's not on the daylight zone. And you see this, a lot of the energy codes, the biggest challenge isn't necessarily in a thing like that. It's when you deal on retail. Retail stores absolutely positively hate it when you when now all of a sudden you've got all these dark zones because it wasn't wired properly. The contractor goes, oh, we'll just take this whole row and don't take the fact that, you know, you have the dark spots in between.
Yeah. And I'm gonna,
I thought there were some exceptions to like retail and.
There are.
retail can have a lot of
Because
extra
of
light.
that, because
They
of
have,
that.
they have a lot of extra light because of that, but I understand what you're saying, and I also understand what you're saying, and you gotta have a customer that you're dealing with, and I have people that are gonna call me and say, well, what do you do on this, and
Well, luckily, I've got the flexibility that I'm placing the lights as well, so I would just like, well, I'll just scoot down and over into the daylight zone, so it's purposefully there, you know, so I don't create these, you know, gray areas. And I'll just bump up the lumens on this one and drop down the lumens on that one, you know, so that the fixtures are, you know, in the zone, the switching that makes sense.
yeah. And it's really hard for the code official that's also looking at everything else
But, yeah,
to, I mean, I personally,
And what about the inspector who has to go out and verify?
but that's why your check sheets are so nice.
yeah, and that's why I'm trying to
That's why
develop,
your check sheets are
that's
so
why I'm
nice,
trying to
because
develop them to, so it walks you
allows
through it.
to move through it versus having to remember all of this stuff.
Yeah.
It's a lot.
It's a lot, and, yeah, it's, we'll move on. That's, I appreciate your input, both, you know, I mean, because it's very valuable to have someone in here, because, you know, I've been exposed to it just because I've reviewed a lot of plans, and I've had a lot of arguments with a lot of people about not wanting to do it. And, so basically, I'm gonna teach you on what needs to happen, and then maybe we're gonna do a class that we just talk about lighting. In fact, I think that's what I wanna talk to you about after, on some resources and stuff like that. Because I think we should do a class, just, you know, there's just so much in here. We should just do a 3-hour class on lighting. And, right? Thank you. I'm not gonna go through all the exceptions, we're not gonna remember them. But,
Please do.
all these guys aren't gonna remember them, and I know you're gonna remember them. Where's the daylight zones? Did you know what a monitor was? I didn't until I started studying the code. I knew what they looked like, but I didn't know that's what you called it. A rooftop monitor where you have light coming in through a vertical window. And it also we're defining where the daylight zone is. We have an obstruction if it's greater than 7 feet, then it's, greater than 70% of the ceiling height, then it's a obstruction that blocks the light. But we have this monitor, or it's kind of a modified skylight, that's right here. And our daylight zone, notice where it goes. Goes here. So what this is saying is it doesn't come back. You with me? And maybe, and I guess this is for the architect and the lighting guy to get together. If you're trying to design that net zero building, then maybe you're gonna mix windows and skylights or monitors or something so that you create more uniform daylight zones where you have a dead spot, you can bring some light from above. I was involved in a project that Architectural Nexus was designing, and they had a building that was basically had a big courtyard, and it was fairly like a 6 or 7 story building that was open in the middle, so it was, you know, it had a daylight zone that came into the middle of the building, trying to get some more daylight in there, trying to reduce the energy cost by getting more daylight into the building. This is talking about that fenestration located in the monitor, and it's kind of, what it is it's describing this condition, so we're just going to skip through it. There's a different type of monitor, but it's still the same type of area. You go 25% of the ceiling height to the sides, and the ceiling height from the back of the monitor all the way over. Skylights, obviously they're going to go all directions, but again, it's 70% of the ceiling height is where our daylight zone is under it. I totally on board completely with most of them. I do have a challenge with a room like this with trying to break them up, and I think you see where I'm coming from, and because I know how tough it is to deal with it as the code official on it. And then where we have atriums and stuff like that, I don't think we need to spend a lot of time there, but fortunately, the verbiage of the code is so hard to wrap your head around by putting a diagram in here. Don't you agree? I mean, does anybody want to read through that and identify? But that's what they're trying to say. I'm just seeing if they're. Nah, we're going to move on. Here's the monitor.
I think this corridor right back here has monitors, if I remember as I walked in.
Yeah.
Yeah.
Roof comes up.
Oh, yeah, they do, right over here. The lights, and then we're talking about things that can be controlled separately. Display and accent lighting. I don't need to read through that. Sleeping units, task lighting. I love it nowadays because my dentist, instead of that sun blasting your face, wears the little light on his forehead, so it's just shining in my mouth and not shining in my eyes. Lighting setback on your landscaping. Building facade landscaping not covered by that, I don't read the section, shall have controls automatically reducing connected lighting power by 50%, not later than midnight, not earlier than 6 a.m. And if I understand this correctly, we might have brighter lighting when people are out and about, and then we don't shut it off, we just drop it to 50%, so we still have some security lighting. And I actually, do they make something like that in the little teeny control that I have in my wall that I can dim?
Wall box size?
In wall box size?
They were making fixtures where
Yeah.
they measured from, you know, when it was a photocell that measured, you know, it knew it got dark here and it got dark, got bright here. So halfway through the night, it knew that, you know, nobody's moved around
Yeah.
here. It's going to get down to 50%. So they built that into the fixture for a little while. I don't think they do that anymore.
I've been one that I've always left a light on, porch light on. And I have porch light and I have a lamp out in the, and I like the security of just having a light on. I don't live in a high crime area or anything like that, but it would be nice if at midnight or something that dropped down.
Yeah. You do, just like your one that you were talking about earlier, your wall box scheduler that turns those lights on at sunset and then turns them off at sunrise. You can get those and then tied into a system, basically a Zigbee system that works on an app that you could schedule that.
Oh,
Turn it on at sunset, and then off at midnight until 5 a.m. and then back on again. So you can do that, and those are pretty readily available.
yeah, yeah,
Amazon.
that's what that's,
Yep.
I think we're starting to see more, bringing the lights down a little closer. Jody Good, Jody retired now, but his big into dark sky and light pollution and all that type of stuff. And you know what, and I kind of agree with him. Lawn, you remember when we were little and we lay out on the lawn at night and sleep out, you could see all the stars? You can't do that anymore. And if you're driving to Moab sometime and you're going down Highway 6 and you get out there past Price and everything, there's a couple of ranch exits. Just pull off in the middle of the night and just get out and pull out a lawn chair or something, because it's dark, and it's incredible. You know.
Well, I was designing something down in Coconino County, that they have the Naval Observatory down in Arizona down there. They wouldn't even let me have a flagpole light that shined up. So I had to shut off the flagpole, or they couldn't have an all-night flagpole light.
Yeah.
Because they wanted the dark sky.
Yeah.
I'm sure everybody's seen the, gas station up on South Mountain. It's just like,
I haven't noticed it.
You can see it from the other side.
That's why Draper has such a tough light.
I'm going to move through and wrap it up. We're hit our time. Garage lighting controls, and I think this is great because there's so many parking garages that have lights just on bright all the time. We definitely can reduce those down, and we have some. And what's really, it doesn't mention it here, but my son downtown, when I pull on Parking Terrace where he lives, I can't remember what they call it. It's brighter,
Yeah.
so that when you pull in the transition zone, yeah, because you come in from the bright, and all of a sudden they actually had some accidents because people were crashing into a pillar that was there. Here's all of exemptions to lighting power calculations, which has something that was added on because of COVID. And so basically, real quick, for those that aren't aware, I think I have a table in here. We have 2 ways to figure lighting power allowances. You can do the whole building based on the general building occupancy, or you can do space by space where you can break it down. And what it's doing is telling you, for this type of usage, you're only allowed so many watts per square foot. And some spaces you can have more wattage, and some spaces you have less. And it's just and so we have the building, or we have the space by space, and we just have some tables, and this is what it tells you. And if you had to do that with incandescent, it'd be dark as can be, and no one could see anything. And
My experience has been space by space, you're allowed more wattage, it seemed like. Like, I did a warehouse just yesterday where I was failing in just by building method, and space, but we back in the space by space, and I was passing by 25%. It was that drastic.
I like to say the energy code is the most flexible code we have. Gives us so many options, but it does ask us to do a lot. Someone mentioned retail lighting. Was that you, Lori? Yeah, you get to add extra wattage depending on what you're selling. And we have a new standard for all you pot growers out there. But actually, there's a lot of stuff that's being grown internally now. Lots of lettuces and stuff like that, and produce. And this is a new term, photon efficiency, that I wasn't aware of. You heard of that, Kyle?
Well, I think I've seen it on the cut sheet before, but I didn't know
Yeah, well, I feel better. I guess it's something about what's important to do you know what photon efficiency is?
I don't know that much about plant.
Okay.
But I imagine it basically comes right along with the illuminant, the efficacy of the fixtures. This is the actual photon output, what they're trying to accomplish, is, I guess, what plant growth
Yeah.
lighting is measured.
Yeah, there's something in what the plants need versus, you know what I mean? That we're producing more of the light spectrum that the plants need, not something else that, our credit options, we've already been through that one pretty good. A couple of real quick things, and then we'll call it, we continue to have additional requirements added to our moving walkways and our escalators, that we change speeds and stuff simply because we have these motors running all the time. And escalator energy recovery, I don't know if you were familiar with this, Lon, or others, but it's virtually, it takes a lot of power to move the people, but it takes braking power to hold the people back when you have the down escalator on. And so if you're trying to slow it down rather than brakes, they want you to put the power back into the grid like a regenerative brake on an electric car. And that's been in code for a little bit. Automatic receptacle control. This was in ASHRAE only until the 21 code, and now at least 50% of the 125 volt 15 and 20 amp receptacles installed in blah, 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 need to be controlled. And if it's modular cubicles, at least 25%. And it's simply to shut power off when everybody leaves. And energy monitoring, if you have larger buildings, you have to measure, monitor, and record energy consumption. And if you have a BMS system, it's already taken care of.
How do you typically see that show up? Because it talks about the being available to the end user, and I don't know that I've ever seen, how that shows up for an end user to access. Because I've seen like the Siemens thing where you scroll through and you see like one line of 8 characters.
I'll ask for some clarification from my son because, in fact, I took it out. I had in a previous presentation. He gave me a couple of reports on a building downtown because them, as the building management group, they have access to all the BMS systems and they track building energy usage all the time because it identifies problems early, and as soon as they see a discrepancy or something that doesn't look right, then they're looking for it.
But this is probably built around changing behavior that, if we have data, we can say, we need to turn our lights off earlier, or we need to put the set point of our HVAC down farther, or, it helps us adapt our behavior. That's why they're wanting that end user.
Yeah.
Because the HVAC, or the physical facilities guy can take that data and say, oh, we've got a filter we need to change or something
Yeah.
like that.
It's
Yeah.
basically the idea, if you can't measure it, you can't manage it.
Yeah, and
That's the whole intent behind it.
He's done very well because he has a computer background, not as smart as my other kid on computers, but he's gone from 4 different management groups and moved up each time because he understands the systems. And he's gone into a building or a set of buildings that were performing poorly, gone to that data, collected it all, gone through and done like retrofits on parking lights. Just recommissioned the buildings a little bit, get them where they needed to be, and they're saving $10,000 and $20,000 a month in utilities, and it's huge.
A great example of that is a lot of companies, they rush to do lighting retrofits, but those that have invested in the even temporary power monitoring will actually find out if they simply put in a few variable frequency drives, they'll actually save much more than they would. Or
Yeah.
soft starts, they'll actually save much more because a lot of times your power, the stuff that you're doing is on driving down energy usage. Whereas as soon as you actually have data on power use and power draw like this, you can actually begin focusing on your peak demand charges, not
Yeah.
just
Yeah.
the power usage. And the peak demand is where, you know,
Yeah.
the real savings comes if you can drive that down.
Successful building management companies are all over it, and they're doing that exact thing. That's it. We're over time. Jacqueline wants to go. I appreciate your time. I appreciate having you guys here and your comments, and you too, Kyle. It adds when we have some experts from the industry that can help me out, and we'll see you next time. If you have any input or anything, glance through this. If you have some questions or if you have some suggestions, I really think what I want to do is to cut it down into for smaller buildings, and we'll talk to you another time.
Yeah, thank you everyone for coming. Again, we have our field training for duct sealing with AeroSeal on May 23rd, and that will be at a house by Ivory in West Jordan. If you're interested in that one, that is a residential. We are also inviting construction instruction June 13th and 14th. 13th will be an all-day class, and 14th will be a field training at a house. So if you guys are interested in that, please join our website. Thank you and have a wonderful day.
Thanks. We'll see you. So, if I were to do a light.